So similarity and symmetry are very important properties, and they show up in a lot of places in mathematics. So we want to make sure that we are able to recognize it and also apply the appropriate math to it. So when we see similarity, we are often talking about equivalent proportions. Okay, so similarity is often seen in similar triangles. So in this case here, this is a problem where we have a lamppost here and it's casting a shadow, and we know that the man is 5 meters from that lamppost. So it tells you the man is 2 meters tall and it wants to know how long the shadow that is cast. Okay, so this man's 2 meters tall this way. So in order to solve a problem like this, we can just let this be x. Okay, and then we can write a similar proportion, okay, an equivalent proportion to be able to solve this. So we can compare, short side to long side, short side to long side. Remember that if the similarity is in the whole triangle, not the partial triangle. So if I were to write this, we can write a trig ratio, okay, 2 to x, 6 to 5 plus x. And I better write that down because this whole length is the length that we're going to need to use, which is 5 plus x. Or we can use the scale ratio, 2 to 6, x to 5 plus x is going to be a times 3 scale. Okay, so I'm going to use a trig ratio here. So I'm going to set it up as 6 over 5 plus x is equivalent to the vertical side to the horizontal side, or essentially slope. Okay, so then solving this is quite straightforward. I'm just going to cross multiply this. Okay, and then we end up grouping our x's together and divide to solve. So I end up with 5 over 2, which is 2.5 meters. Okay, so the length of that shadow is going to be 2.5 meters. The length from the lamppost to the tip of the shadow is 7.5 meters, and you can see the ratios are, in proportion to each other. So symmetry is a very important part of math. So anytime we have symmetry, there's some math embedded in it, and it gives us extra information. Okay, so we always want to take advantage of symmetry when it exists. So when we talk about symmetry, okay, in the trig function, there's symmetry vertically. Okay, there's symmetry rotationally around that point. Okay, we can rotate around that point. We can slice in half. Okay, across that line there's symmetry. There's lots of symmetry involved here. So here I've given the general equation, a sine of 2 pi over b x minus c plus d. We know that the vertical shift is plus d. We have a horizontal shift of c, a period of b, and an amplitude of a. So what you're being asked here is find the coordinates of the P, A, P, B, P, C. So this point here, this point here, and this point here, in terms of the coordinates, the coordinate parts A, B, C, and D. So here is the start of the sine function. So it's a horizontal shift of C, and the middle line is D. So that's going to be CD as our starting point on this graph. Okay. The reason why we get this point as C plus B is because we know from here we're going to add one period to get one full cycle from E to D. So point A we have to find using some symmetry here. So what kind of symmetry could we use? Okay, so there's a symmetry of the whole circle, okay, half the circle, and there's also quadrant symmetry here, where we have this quadrant is equivalent to this quadrant, it's equivalent to this quadrant, it's equivalent to this quadrant, etc. Okay, so we can do that as well. So there's lots of ways to do it. The most efficient way is to find middles. Okay, so in terms of middle, we just want to find halfway point or the arithmetic average. So I'm going to start with PB. Okay, so point B. Okay, this point here. I know that the coordinate of that, the y coordinate, must be D because it's going to share the same y coordinate because it lies along that line. The x coordinate, however, is going to be halfway between C and C plus B. Okay, so if I want to find the x-coordinate of B, I can kind of measure halfway, but I can do that fairly easily by using this half-point formula, or the midpoint formula, which is basically the arithmetic average. So I add those two together, I divide by 2, I get 2c plus b divided by 2, so 2c divided by 2 is c, plus b divided by 2 is b over 2. So if I just go half the period, I get to that point. So that's going to be my middle point. Okay, so that's the x-coordinate of that point right here. So let's take a look at this point here. This point here is halfway between these points, okay, or basically a quarter period. So we can add a quarter period to get there, but I'm going to do the exact same thing as I did before. So I'm going to do point C. So D, the y coordinate, is going to be at D, and I'm going to go down by the amplitude. So I'm going to go D minus A as the y position. For the x position of point C, I'm just going to do the average again. So I'm going to take that point at B, C plus half B, plus the point at C plus B, so that's going to be C plus B, divide that by 2. Okay, so I'm going to end up with 2C divided by 2 is just C again. 1.5 B divided by 2 is 3/4 of B. Okay, so there's my coordinate, C plus 3/4 of B, which makes sense because if I start here, that's 3/4 of a period to get to there. Okay, so if I want to then find out point A, which I'm going to do in green, that point here, well, I can look at this distance from here to here. That distance is exactly the same as from here to here, because they both represent 1, 2, 3/4 of a period. So there's a quarter period, 2/4, 3/4 of a period. I know the y position of that coordinate, so I'm going to write the y position first. So point A, the y coordinate is just going to be the middle point D. Now I'm going to, instead of going down by the amplitude, I'm going to go up by the amplitude A. And then if I want to get to that point, I'm just going to take the coordinate at C, and I'm going to go backwards the same amount I went forwards to get to point C. So I went forwards 3b over 4. So I'm going to start at C, and I'm going to go backwards that exact same amount. Okay, so I'm just using the symmetry from that point. Okay, the distance, if I draw a line here, this distance is equivalent to this distance here. Okay, that point, that distance there. Those are equivalent distances because of symmetry about that point. Okay, it has horizontal symmetry. So there it is. There's my coordinate in terms of B, C, D, and A.